Is that the bio?
Let's see if you understand it.
Sounds like a bio.
See if you can make it through.
Oh my goodness.
So that's an 8. It's not very good, 8 is.
It's recording, yes.
So it looks like a lot of people got A done, so let's go ahead and do that. So I've got HClO plus H2O goes to ClO minus plus H3O plus. I start with 0.2 molar. We'll start with 0xx. So I've got 2.9 times 10 to the minus 8 equals x squared over 0.2. I don't remember what that number is.
7.6 times.
What do you get for x? What?
7.6 times 10 to the negative 5th.
7.6 times 10 to the minus 5th, which is your H3O plus. So your pH is 4.12. I think that's what I saw everybody get. Okay. So that hopefully is real easy for everybody. Hopefully you got this down. If you're struggling with that one, you need to work on it some more. Make sure you get it. Okay. But now I added some sodium hydroxide. So I have this going on. Oops, that's not right. Okay. Okay. So, I don't know, how do I solve that? Take Chem 1. Okay, Chem 1. We're gonna go back to basic Chem 1 stuff. So first thing you're gonna do is you're gonna write the equation. Second thing you're gonna do is, well, okay, yes, we're gonna write a balanced equation. Okay, so first thing we're gonna do is we're gonna write a balanced equation. Second thing we're gonna do is find the moles.
Yeah.
And why are we finding the moles?
Because you want to get the mole.
Because you want to know what the limiting reactant is,
Yeah.
right?
Yeah.
You guys remember that from Chem 1,
Yes.
right? We did this, oh, you didn't do that in Chem 1?
No, we did. It was just
Oh.
like a year ago.
Okay. All right, so I got 150 mils, 0.2 molar solution. How many moles is that? Like 0.03? Okay, I got 0.03 moles of this guy. And I've got 10 mils of a 0.5 molar solution, 0.005?
Yeah.
0.005. All right, what's my limiting reactant?
The NaOH.
NaOH. So by definition, limiting reactant, I don't have any left, right? So that's how many moles I got left,
Yeah.
right? How many moles of this do I have?
0.005.
I start with 0 and I'm plus 0.005, right?
Yeah.
Yes.
Why is it 0.03 moles?
Why is this one?
Yes.
That's right.
0.20 moles per 1 liter equals X moles over 0.15 liters. All right, I've got 150 mils of 0.2 molar solution. If I solve for X, I get 0.0. Okay, are we good with the Chem 1 stuff? Okay, these are the moles that are going to be the initial value in that equation. Okay, we're going to turn this back into, so let's turn this back into concentration, because that's got to be concentration, right? So this is how many moles of HClO I have. How much liquid do I have now? How much liquid's in my beaker?
150 milliliters.
No,
No.
160 milliliters.
160 milliliters.
I have 150, I just added 10 mils,
Yeah. Yeah. 160.
right? So 0.16 liters. divided by 0.16 liters. These are both in the same solution. So this is what molarity? I don't know what that is.
Which one? Sorry, I did everything. 0.156. 0.16.
And this one?
0.0313. Or 3125.
Why is it 0.16 liters?
Okay.
Because it's 150 milliliters of one and then 10 milliliters of the other.
And I hear you. What did you say, Professor?
So in part B, that would be B. And I'm doing this the long way so you can see all the steps that I'm doing. Because normally I kind of skip this over here, but I'm doing this to help you out. Okay, so these are my starting numbers. I have, after adding 10 mils of stuff, I have 0.156 molarity HClO left. I have 0.031 molarity. And at that point, it works just like a regular product. Right? Notice sodium hydroxide's gone. It was a limiting reactant. So when you're titrating it in, it disappears because it reacts with the acid.
Why is it 0.16 liters?
Why is what?
Why is it 0.16 liters?
Because I started with 150 mils and I added 10. So I have 160 mils. Aren't we adding base to it? We're adding base, pH goes up. pH started at 4.12, pH get higher. So, what do we have here? So 2.9 times 10 to the minus 8 equals x plus 0.031 times x over x minus point, oh, oops, go backwards. 0.156 minus x. Right? So, if x is small relative to 0.031, we can drop both of those x's. Make our life much easier. And so my x, I don't know, whatever you get.
Yeah,
1.16? 46? 1.46 times 10 to the minus 7. I bet you square rooted it again, didn't you? Is that what you did? Yeah. Okay. But that's actually just x, which is, once again, our H3O plus. So our pH is 6 and something?
6.84.
6.84. Okay. And you can check yourself, like we had to do over here. He square rooted it accidentally, and he got a number that was like 3.5. Well, you can't add a base to an acid and have the pH go down, right? So you know, whatever my answer is, it's got to be bigger than 4.12. So that's a check on yourself, that you know, and as I add that base, my pH had better be going up. you know? And I'll tell you, you know, just being able to recognize that your answer sucks is worth points. Okay? If you're doing a test, you run out of time, and you say, God, my answer should be bigger than 4. I got 3.5. You know, you writing on the test, my answer should be bigger than 4, and I got 3.5. I don't know where I went wrong. That could be almost full credit, depending upon how badly you screwed up. But you know, right? At least you recognize where the answer should be. That's something. That's the real skill. Okay, so we've done A, we've done B. How many mils to get to the half equivalence point? Half equivalence point, what is that?
It's where pH equals pKa.
Well, yeah, but where is it?
Halfway
Half the
here,
milliliters to the equivalent.
Halfway to the pH?
or the midpoint
To
of
the
the start
equivalent.
point.
It's where the NaOH is half as big as the ACL,
Yeah.
right? Because if they were the same value, we'd be done. If we're halfway to done, that's where we are. Okay? Well, how much is that?
What is it? So just wait.
So this is still 0.03. If I'm at the half equivalence point, that's going to be a 0.015. Because that's halfway to done, right?
Yeah.
Not that I actually need this because I didn't actually fund this pH. Okay? So, how much sodium hydroxide did I have to put in there to get 0.015 moles of NaOH that I put in the solution? Put in 0.015 moles of NaOH. How many mils of solution?
Oh, this is, yeah. That'll be in liters. You want another mils, that'll be 7.5.
I think so.
Doesn't feel right.
10 mils was only 0.005, right?
Yeah.
So it should be 30 mils, right?
Yeah.
I have 0.5 moles per liter. I want 0.015 moles. How many milliliters?
Any liters.
So it's 0.015 because we found 0.03 for HClO.
Mm-hmm. And we need half that because it's the half equivalence point. Okay. So C is 30 mils. Well, that should make D easy. How many mils to get the equivalence point?
60.
If $1 will buy you half candy bar, how many dollars to buy a whole candy bar?
$2.
$2, right? Yes, sir. Where neither one's living there. That's the equivalent point, is where both of them, both reactants go. Not necessarily. Okay, so we all got our equivalence point, right?
Mhm.
60 mils? Awesome. Okay, what's the pH at the half equivalence point?
PKA.
The pH is equal to the pKa, right?
Yeah.
Let's go through that again so that those of you, if you didn't get it, you know. At the half equivalence point, that's 60 mils, right? So that means I have 0.015. 60 mils would be 210 mils total in the beaker. Oh, half equivalence point, I'm sorry, half equivalence point, so we're at 180. Okay, so what's the molarity here? What is that? 0.17? This is 0.15 divided by,
Why is it 0.1?
because I start with 150 mils and I added 30 mils. You guys told me it took 30 mils to get to the half equivalence point,
Yeah.
right? So I've added 30 to my 150, so I got 180. What's this number?
0.083.
0.083. Okay, so I start with 0.083 molarity, but this is also 0.083 molarity because, right, I have plus 0.015 divided by 0.18. I get the same thing over here.
Yeah.
Okay. So 2.9 times 10 to the minus 8 equals 0.083 plus x times x over 0.083 minus x. Drop the x's, drops the 0.083s, and can you see that hydrogen ion equals Ka? So pH equals pKa, which is like 7.5 or something.
Yeah, 7.54.
Okay. So pH equals X, well, it's not equal to X, but it's equal to 7.5.
Negative log.
Okay. Okay, how about the pH at the equivalence point? So what's in my beaker at the equivalence point?
No more HClO, just nothing.
All I have is Na plus, ClO minus, and water,
Yeah.
right? Because the definition of the equivalence point is I don't have any reactants left. Reactants are gone, okay? Huh, I only have ClO minus, which is, how is ClO minus related to HClO?
Conjugate base.
It's the conjugate base. So the only thing I have in my beaker is a base.
It's gonna be basic.
Well, it's not really a conjugate anymore because now that's the only thing there is now a reactant.
Yeah.
Okay? So what kind of thing do I need to use if I have a base?
KB.
KB? Yeah.
Oh, when you do. Yeah. Okay.
So all I have in there is this. Right? All I've got is the base. So the base reacts with water. Bases are proton acceptors, right? So they gain a hydrogen. Took it from the water, so I have OH left. Okay? So what is my molarity of base at the beginning? What's my initial molarity of base? You go figure out what your initial molarity of base is. How many moles of that base do I have?
0.03.
Can you see I've turned it all my acid's been turned into conjugate base, right? So my 0.03 has gone to 0 because I'm at the equivalence point. And so my conjugate base has gone from 0 to 0.03. Okay, what's my volume now? How many mils did I have to take to get to the equivalence point? 60. So how many mils are sitting in the beaker?
210.
210, right?
Yeah. That's what I was.
The 150 I started with plus the 60 I had. Let's see if that's enough for you guys to get an answer. Let's see if that is. So my CLO is my 0.03 moles divided by 210 mils.
Yeah.
1/7, so 0.14 molar.
Yeah.
What goes over here?
1 times 10 to the negative 14th over K.
This is going to be my KB, right? So if this is the pH to half equivalence point, that means this is PKB right here. That's PKB, PKA. So PKB is going to be 6.46.
Yeah.
All correct. So I got a number for what X is?
2.23 times 10 to the negative 4th.
Anybody else get that? 2.23 times 10 to the minus 4th? Yeah? Okay, cool.
Is it K, KB because it's the full equivalent?
So if I take the negative log of that, what do I get?
Uh, 3.65. That's POH.
But in this case, notice X is OH. So this is my POH.
So why is the subscript B KB?
Because this is a base,
Oh,
K base. So my pH is 10.35.
Yeah.
Okay, if you can do this, problem, then you've got what's going on with acids. Because that's basically everything we talked about on acids, except for the whole Arrhenius versus Bronsted-Lowry idea. But that's pretty trivial. Okay. So that's what's going on with acids and bases. Now, I want you to notice this last one where we were the pH of the equivalence point. Notice what that means. That means that there are a lot of salts out there that have an identifiable pH. Because a salt, the chemical definition of a salt is the product of an acid-base reaction. Okay? So anytime you react an acid and a base, you're going to get water plus a salt. Okay? So that doesn't necessarily mean table salt. In chemical terms, a salt is any product of an acid-base reaction. So if I react copper hydroxide and sulfuric acid, I get copper sulfate in water. So copper sulfate is a salt. Okay? It's not what I want to put on my French fries, but it is a salt. Okay? And so a lot of those salts have a pH. They're going to influence the pH of your solution, like this ClO minus here. So you can imagine I could have asked this question. This would have given me the exact same answer. If I said, what is the pH of 0.14 molar sodium hypochlorite? You would have got exactly the same answer, doing it exactly the same way. Because sodium has no effect on pH because it's the conjugate acid of a strong base. And so that ClO minus is the only thing up there that's affecting pH. It doesn't matter whether it's part of a titration or whether it's a salt sitting in a beaker or whatever, it's still, that's good. If you have 0.14 molar sodium hypochlorite, it's going to have a pH of 10.35. Okay? Well, let's see whether you believe me. Let's try one, see if you So, what's the pH when you take 15 grams of sodium acetate and you add it to enough water to make 250 mils of solution? If the pKa of acetic acid is 4.7. So somebody want to help out those who forgotten their nomenclature? What is the acetate ion? What is that? C2H3O2. Yes. Because you do actually need the formula for this one. What'd y'all get for molecular weight of sodium acetate? You had 82?
Yeah.
Let's see, you've got it. So, how many moles of sodium acetate do I have? 15 divided by 82? 0.18?
Yeah.
So, 0.72 molarity? Okay, so there's my initials. So I have acetate, it's gonna react with water to give me acetic acid plus H3O plus. And my initial is 0.72. So x squared over 0.72 minus x, well, I'll ignore that, is equal to
10 to the 14 minus pKa.
yeah. So the pKa is 4.74, so the pKb would be 9.26.
Yeah. Yep.
Yes. This is a base. But we have the pKa for this, right? So we have a pKa going that way. We don't have the pKb going this way. So we've got to do the 14 minus pKa plus pKb. So I don't know. Got a pH? Something?
My calculator's good, so.
Yes.
But if it's a base, what is it?
Oh, you're right. There's my mistake right there. Oops, sorry. Yeah. Good catch on that one. Okay, there we go.
And it has a negative charge on the reactant side.
Has a negative charge on both sides. I mean, there is,
Sodium acid.
floating in the beaker, there is sodium ions, right?
Yeah.
There are sodium ions that are counter ion to this, but they don't do anything, so I don't care. Those same sodium ions are gonna be over here.
Countering.
The solution is electrically neutral. I just didn't write the I mean, I could do this. Right?
So in the future, we should assume they're two separate things, like in the problem.
One or two separate things.
Sodium and acetate.
Yeah.
Well, yeah,
Yeah,
they,
yeah.
yeah. They can speak.
Means it's a complete. It's a strong electron.
Sodium is the conjugate acid of a strong base. So it has no effect on pH. The conjugates of strong acids and bases do not influence pH. So if I gave you sodium acetate, the sodium doesn't have anything to do with pH. I'm asking you for pH, right? And the sodium, as the conjugate acid of a strong base, does not affect pH. So I can put it in there or not put it in there, but it's not going to affect pH. Now, if I was cruel enough to give you something like copper acetate, where copper is weak acid, you know, the conjugate acid of a weak base, and acetate is conjugate base of a weak acid. Okay, now things get complicated, and that would be super cruel, and I'm not going to do that to you. Okay, so don't worry about it. So I'm not going to do that. Could you figure it out? Yes, but the math gets hairy at that point because you've got everything interacting with everything else, and you got to figure out what's going on. All right. I don't know. We never did figure this out. What is this?
What is that?
2.0 times 10 to the negative fifth.
Negative fifth?
Yeah.
Yeah.
So my POH is 4.3 or something?
4.7.
4.7.
Yeah.
Yeah, that sounds better.
So the pH is negative 3.
Are we getting there?
Yeah.
Getting closer?
When do we know to subtract it and get it to pH? When did that become
When you solve for X, you ask yourself, what is X? What does X stand for? And in this case, X stands for OH. Right? I mean, if I just look at the equation up there, X stands for OH. So when I take the negative log of it, I get the POH. And pH plus POH equals 14, right? And I asked you for pH, so you have to determine. I could have asked for POH, right? I could have said, what's the pH of the solution? And it would directly solve for POH. It's just that if I tell you the pH of a solution is 6, you still don't know whether you should stick your finger in there because we never use it. You know, it's not what we use very often.
Yeah, it's neutral.
Oh, here's one. Let's try this. Okay. Acidic solutions are sour. Basic solutions are slimy. Okay? They're like soap and that kind of stuff. Okay? So you got something that's got a POH of 5. Is it slimy or sour?
Slimy.
Slimy.
Yes.
Because it has a pH greater than 7, right? It's got a pH of 9. It's got a pH 5. Assuming I said 5, I think I
You do.
Okay. Right. Okay. I want to do one more kind of non-mathematical hand-wavy kind of thing. And that is so if I have some of both the acid and the conjugate base. Okay?
Wonderful.
So we're in equilibrium. I've got some, I don't even care what the numbers are right now. So I've got some of both. Okay? If I add acid to that solution, according to Le Chatelier, which direction is it going to go?
Products.
I add acid to the solution. I'm at equilibrium. I add acid to it. Which way does it go?
To products.
I add acid. Is that products? Right? I just added acid.
Oh, a different acid?
I didn't add this acid.
Oh.
I added generic acid.
Okay. Reactants.
Oh, sorry, that was the problem. Okay. So I just add some generic acid, something totally different, HCl, whatever.
Okay.
Yeah, it goes for it.
Okay?
Yeah.
It's gonna go back to products, right? Okay. So you can imagine that this is the equation. It would be something like Ka is equal to X. Well, I probably shouldn't use X, should I? H3O plus times the A minus over the HA, right? But look what happens. When I add acid to a solution, I'm adding when I go from pH 6 to pH 5, I'm adding basically 1 times 10 to the minus 5th molar H, right? That's how you get from pH 6 to 5.
Yeah.
Now imagine I've got like a 0.5 molar solution. So let's say this is 0.5 and this is 0.5, and now I add 1 times 10 to the minus 5th. Can you see that it's not going to change that number?
Yeah.
Because I'm going to basically subtract 1 times 10 to the minus 5th from my 0.5.
It's not a big
And I'm going to add 1 times 10 to the minus 5th to my 0.5. So when I added 1 times 10 to the minus 5th molar, yeah, it's going to shift this way to exactly where I was before.
Yeah.
Because these numbers are going to basically stay the same. That's a buffer. That's what a buffer is. A buffer is when you have a big pile of acid and conjugate base, so that when you add some acid or base to it, those big piles of acid and base, the numbers don't change. And if the numbers don't change, the pH ends up being the same.
Okay.
That makes sense?
Yeah.
Cool. Friday we'll put some math to it. See you.
I got 6 homeworks instead of 6.
I didn't pay attention at all in Wednesday, and I still got credit for it.
And how many homeworks did you get?
I did my chem homework.
So you did 1 homework.
That's just because I'm bad at chemistry. Calculus.
Oh, there's a Wednesday workshop for health?
Yeah.
Is it like required?
No. I get extra credit for it.
Oh, okay, yeah, because no